The Lesson 7. Utilization of Prefabricated Vertical Drains, PVDs, in Railway Embankment Construction over soft soils.
Prefabricated vertical drains, PVDs, are a crucial solution for stabilizing soft, compressible soils in railway embankment projects. Their use ensures faster consolidation of the soil, improving its strength and reducing settlement risks under the heavy and dynamic loads imposed by rail traffic. Below is a detailed explanation of their application. 1. The challenge. Soft soils such as clay and silt often exhibit low bearing capacity, high compressibility leading to excessive settlement, long natural consolidation times due to low permeability. For railway embankments, such conditions pose risks of uneven settlement and instability, which can affect track alignment and safety. 2. Role of PVDs. PVDs accelerate the natural consolidation process by providing vertical drainage paths for pour water in the soil. This allows the soil to strengthen more rapidly under applied loads, such as the weight of the railway embankment and trains. 3. Process of implementation. A. Site investigation. Comprehensive geotechnical studies are conducted to determine soil type and compressibility, depth of the soft soil layer, expected settlement and consolidation time. B. Design and planning. Spacing. PVDs are laid out in a square or triangular grid pattern with spacings typically between 1 to 3 meters. Depth. Drains are installed to the bottom of the compressible layer. C. Installation. Preparation. A working platform is created using granular fill material to support installation equipment. Drains installation. A mandrel, steel casing, is driven into the ground to the required depth using a hydraulic rig. The PVD is left in place as the mandrel is withdrawn, anchored at the bottom to prevent displacement. Preloading or surcharge. A temporary load, usually sand or fill, is placed on the embankment site to accelerate soil settlement. Drainage. Pour water escapes through the PVDs, expediting consolidation. D. Monitoring and adjustment. Settlement plates, piezometers, and inclinometers monitor the progress of consolidation. Adjustments to the preload or drainage layout may be made as necessary. 4. Benefits for railway embankments. Faster construction timeline. Reduces the consolidation time from years to months, enabling quicker project completion. Increased stability. Ensures a uniform and stable foundation, reducing risks of differential settlement. Cost effectiveness. Avoids the need for expensive soil replacement or deep foundations. Compatibility with rail loadings. Enhances soil strength to withstand heavy and dynamic loads.
Dear ladies and gentlemen, for more lessons and lectures, you can download this book from Amazon Kindle. Thank you for watching, my dear friends. Don't forget to like and comment on the video.